So the second part of 4.3, you know, like function values for some special angles. This is a lot of the same stuff that we already talked about whenever we dealt with the unit circle project, or we talked about a lot of those things. So, you know, it says use your unit circle. You don't have a unit circle, but you have one, again, like we've talked about with your left hand as far as where everything's going to go. So remember, if we have, remember the cheat sheet that we have fingers here. Okay, so we have 0 degrees, we have 30 degrees, we have 45 degrees, 60, and 90. Remember that cosine of anything is going to be on top, and then sine of any value is going to be the bottom set of your fingers, okay, on your hand. Remember that everything is square root over 2. So if we are, like it says, use the unit circle to find sine of 45 degrees. So, and then last thing, that remember that tangent is just equal to sine over cosine. Okay. So if I have sine of 45, so I'm going here, that's where I'm going to bend everything. Okay, if I'm going to deal with sine, so I'm going to look at my, how many fingers do I have below the red? 2. So sine of 45 degrees is just going to be the square root of 2 over 2. Same way with cosine of 45 degrees. It's the numbers that are left, so if it's bent at the middle finger, okay, how many fingers do I have above the bend? 2 again, right? So cosine and sine are both going to be the same. And then whenever we find tangent of 45 degrees, all I'm going to do is take what I have. I'm going to take the square root of 2 over 2 divided by the square root of 2 over 2. And again, it's division of 2 fractions, so it's really up to you as far as how you want to do it. If you want to stack everything and do it this way, that's fine. Or if you want to do keep, change, flip, what's going to happen to everything? Everything cancels, so what am I left with? Just 1, right? Same way whenever we deal with sine of 60. So instead of, let's put the 45 degrees back on. So now, since it's 60 degrees, or since I'm dealing with, it's 60 and 30. So if it's 60 degrees, I'm going to have what's in yellow. So sine of 60 degrees and cosine of 60 degrees. What are my two values? Square root of 1 over 3 is going to be my cosine, or square root of 1 over 2, excuse me, is going to be my cosine. So square root of 1 over 2, which is really just 1/2. Sine is the bottom 3 fingers, so these 3 here. So the square root of 3 over 2. Now, whenever I do the same thing, but I do it for 30 degrees, so if I have sine of 30 degrees and I have cosine of 30 degrees, everything's still the same, but now I'm going to deal with the green side, right? So yellow's gone. So that was 60 degrees, that was 45 degrees. So now what's going to happen to like the square root of 3 over 2 and 1/2? Like what is sine? So sine is the bottom side. So if I'm bending here at my ring finger, basically, okay, how many are below the ring finger? 1. So square root of 1 over 2, which is just going to be 1/2. Do the same thing, but now do it for cosine. Okay, cosine of the top 3 fingers, so my thumb, my index, and my middle finger. So I have 3 of those. So I'm up here. So I'm at square root of 3 over 2. What do you notice about the values? Yeah, just switched them, right? So sine of 60 and cosine of 30 are the same value. Cosine of 60 and sine of 30 are also the same value. Okay, so just kind of be cognizant and aware that of what you have, especially for the 30, 60, 90. It's really the same triangle, it's just the angle's in a different spot. Okay. Then whenever we talk about trig functions and their complements, okay, remember if it was a complement or you had complementary angles whenever you were in geometry, that just meant that they added up to 90 degrees. Okay? If a full triangle adds up to 180 and we have a right triangle, so 90 degrees is taken up by one angle, the other 2 angles are going to have to add up to 90 degrees. Okay? So their sum is going to be 90 degrees or pi over 2, whatever you're dealing with, whether it be in angle measurement or, bless you, radian measurement. So what it says is basically common sense. It's just a matter of making sure that you know which ones go with what. So any pair of functions for which f of theta is equal to g of 90 minus theta, okay, and g of theta is equal to f of 90 degrees minus theta are cofunctions. Basically what that means is if you take sine of a value, whatever your angle measurement is, it doesn't matter if it's like down at the bottom, if it's 72 or if it's pi over 3, depending on cosecant, sine, whatever. Okay. If you notice that you have your cofunctions here in the yellow box, that the cofunctions of sine are cosine, whereas the cofunctions of tangent and cotangent, and then secant and cosecant. Okay? It's in the word, right? Because it goes from sine to cosine. It goes from tangent to cotangent. It goes from secant to cosecant. Cofunctions, co in front of the other value, right? Don't overcomplicate it. It's really simple. You have sine, put a co in front of that, or if you have like on B, you have cosecant, take the co or the first 2 letters off of it. You're either putting 2 letters on or you're taking 2 letters off to find the cofunction of whatever angle or whatever function you have. And all you have to do is just take 90 minus whatever angle measurements, whatever's remaining. Okay, remember, you already have a 90 degree angle. The other 2 have to add up to 90. So it's whatever you have left. So if I have cofunctions with the same value as the given expression, so if I have sine of 72 degrees, what is the cofunction? What is the cofunction of sine?
Cosine.
Cosine. Very good. Thank you, baby. So cosine. Now, what do I have to do with the 72? What is 90 minus 72? 18. So sine of 72 is going to be the same as cosine of 18. Okay, the ones that are going to be a little tougher, okay, are not so much that it's too terribly difficult, but it's a matter of, you know, if you have it's in radians, you're going to want to change this, you know, replace the 90 degrees with pi over 2. So what I've got to do is essentially, so first off, if it's cosecant, what's my cofunction? Secant, okay? So usually that's not the problem, so it's going to be secant. Now it's a matter of making sure that I get whatever's left. So if I'm taking, like before, I took 90 degrees minus whatever value that I was given, and then it gave me whatever was left. Whereas here, it's in radians, so it's going to be a little bit tougher. But really all it is a fraction. Okay, so what is 90 degrees as a fraction? Pi over 2. Okay, pi over 2 is just 1/2 pi. Is all it is. Okay, so if you write it as pi over 2, it's the same thing as 1/2 pi. Now, I need to subtract pi over 3. So that's the same thing as subtracting 1/3 pi. Now, for me to actually subtract fractions, what do I have to have? Common denominator. So what's common denominator between 1/2 and 1/3? 6, right? So 3/6 minus 2/6. So how much am I left with? 1/6 or pi over 6? Now, if you're given like nice and neat values like pi over 3, pi over 4, pi over 6, okay, it's really just going to become a matter of like what is pi over 3? Pi over 3 is really just what angle? Is it the 30, the 45, the 60, or the 90? It's the 60, right? So what's 90 minus 60? 30. What's the radian measure of 30 degrees? What's the first finger, or really the ring finger? Pi over 6, right? Okay. So on ones like that, when it's in radians, you can kind of simplify it. If it's easier for you to go into degrees and go that route, do that. Okay. But really, all pi over 3 or pi over 6 or pi over 2, they're just fractions. Okay, is all it is. Get the denominators to be the same and go from there. Now, whenever we use, and you did this, you should have done this in your geometry class a couple years ago with angle of elevation and angle of depression. Okay, so whenever, like it says, angle of elevation is the angle formed by a horizontal line and a line of sight to an object that is above that line. Okay? So basically, whenever you are standing wherever, you have a line of sight, basically if you look your eyes straight out. Everything above that line, okay, everything like if we're standing on the ground, everything above your eyes is going to be line of sight above your observer or your angle of elevation. Everything, if I have to look down, okay, or look to the ground, is going to be angle of depression. Okay? Even if I'm just standing on solid ground and I look to the floor, there's still an angle of depression that you will have. Okay? You don't have to be elevated, okay, or in a building or in a plane or whatever. Okay? It's just a matter of making sure that you go off of where everything is with your line of sight. So whenever it says, sighting the top of a building, a survey measured the angle of elevation to be 22 degrees. The transit is 5 feet above the ground and 300 feet from the building. Okay, so it says find the building's height. So you have 22 degrees from the line of sight. Now, the one thing that you do have is you have an extra 5 feet as far as like where the like what he's using to survey. It's not going to survey from the actual ground. It's going to be on a pedestal or like a tripod and then shooting from there. Okay. So what we have to find is you're going to use right triangle trig. So whenever we do that, we have to first, like what I would suggest for you is to figure out what A is first, and then tack on the extra 5 feet that we have down here. Okay, because it wants to know the actual height of the building. Okay, so if we have 22 degrees, we have 300 feet. What is A? Is A opposite, is it adjacent, or is it hypotenuse of my actual triangle that I have here? It's the opposite side, right? What is the 300 feet? What does it represent? Does it represent the opposite side, the adjacent side, or the hypotenuse? The adjacent side. So if it represents the adjacent side of my right triangle, okay, which one of my 3 main functions have opposite and adjacent in it? Tangent. So I'm going to take tangent of 22 degrees, and it's going to be equal to opposite, which is A, over 300. I need to solve for A. Okay, I'm going to find the building's height. It's going to give me a random decimal. Okay, that's okay. So first off, before I do anything, I need to make sure that I get A by itself. So how am I going to get A by itself if it's A over 300? Multiply by 300, right? If I multiply this side by 300 and the tangent of 22 by 300, then I'm looking at 300 tangent of 22 degrees is equal to A. Alright, so if you're dealing with a graphing calculator, first thing you want to make sure is go to the mode and you want to check to see, it'll probably be about the second or the third line where it says radian. I'm given 22 degrees, so I need to make sure that it's in degrees. If you have a scientific calculator, it needs to say DEG at the top. Okay, if it doesn't, you'll just hit the DRG button with the little arrow and it'll change it to like radians, gradians, or back to degrees. Okay, so before you do anything, you have to make sure you're in the right mode, so then we can just arrow over to degree and hit enter, and it should be highlighted. Okay, then it just becomes as simple as, so I'm just going to quit or get out of that. So it was 20, or it was 300, so I'm just going to hit 300 times tangent of 22, and then close the parenthesis. This is going to give me the height of A. All right? So in this case, A is 121.21 feet. Okay, so if I go back here, and it gives me that A is equal to, we had the 300 times tangent of 22 degrees was equal to A. So A is equal to 121 point, we'll just say 121.2. Now, is that my final answer? No, why not? Because we've got to add that 5 feet that we had, basically the distance from here to here. Okay, so all I'm going to do to find the height of my building is I'm going to take the 121.2, add 5 to it. So the actual height of the building is about 126 feet, 0.2 feet. Now, last one. This one's just going to work in reverse. So before we were given an angle, now we need to find the angle. Okay, again, we want to know, it says building is 21 meters tall, casts a shadow 25 meters long, find the angle of elevation of the sun to the nearest degree. Okay, so we're actually trying to find the degree. So the steps in which I do everything is going to be a little bit different. So now that I'm trying to find theta, what is 21? Is 21 opposite, adjacent, or hypotenuse to my angle that I have? It's opposite. So it's opposite. 25 meters then is going to be adjacent. So am I going to use sine, cosine, or tangent? Still tangent, right? So I have tangent of theta is equal to 21 over 25. Now, these are actually probably the easiest of any of them. Again, I want to find the nearest degree, so I need to make sure whenever you have anything like this that I am in degree mode whenever I go to my calculator. What I'm going to do is I'm going to use the inverse function. So it's going to look something like this, where it's going to be negative, like tangent to the -1, and then I'm just going to type in my equation, or my fraction. So whenever I go with this, I'll have to hit second, and if you notice that there's like a tan with a tangent with the -1, you can't see it here, it's a little, so I'm going to hit second and then tangent, and then I'm just going to type in my fraction. Okay, what was it, 21 over 25? Is that right? Close the parenthesis, hit enter. So round it to the nearest degree, I believe is what it said. So 40 degrees.